wait for another 1 minute. Any questions so far from others? Okay, don't have, so I believe everyone is back already. Now we have covered mean and median. You can see that for raw data, quite straightforward to find the mean and also the median. But for the group data, the one with the table and the frequency one, there's a lot more works to do. Correct or not? So let's go to the last one, the mode. So actually mode is the most frequently occurred. If you ask me what is mode, mode refer to the highest frequency. We can call it highest, the frequency which is the highest lah. Or some textbook they use the word most frequency, most frequently occurred. That happen the most time one lah. Now mode sometimes don't exist, and sometimes if happen it is not unique. Not unique means it can be two same value happen same time and recorded the highest one. So it we call bimodal and so on. Okay, I'll show you one example. Now for raw data again, again we have to look at raw data and group data. So let's look at the raw data first. We arrange the data in ascending, same like the median, and then we look at the frequency which is the highest or we call it the most frequently happen. So for example, these are the data for showing in 8 families, there are number of children. So one family have 2 children, second family have 2 children, 3 family have one family have 3 children, one family have 4 children, and so on. So find the mode. If you arrange the data 0, 1, and 2, 2, 2, and 4, 6, right? So you can see here the most one is what? 2, 2, 2, because there are actually 3 occurrence, and that means there are actually 3 families with 2 children. So 2 is the mode. Okay, so you can comment that. Now let's look at more example. 1, 2, 3, 4, 7, 9. 1, 2, 3, 4, 7, 9. There's no answer for mode because all data happen once. Okay, only one time. You see, all only appear one time. Okay, let's look at example 2. 1, 2, 2, 3, 4, 5, 5, 8, 8. You can see 2 and 5 everyone. Both of these numbers happen 2 times. So there are actually 2 modes here, 2 and 5, because got twice occurrence. Twice. And this is called, 2 modes means we call it bimodal. There's a special name for this bimodal. Okay? So you see the mode is not unique one. Not unique. Sometimes there's no mode, sometimes only one mode, sometimes can be 2 modes, and so on. Not necessarily there is a mode. Okay, this is for raw data. Again, raw data very straightforward. You just find the highest frequency. For group data, again, like the mean and median, you have more works to do, because similar to median, you need to locate location. Remember the location for the mode class first. Again, the mode class, as I said, how you determine the mode class? You look at the frequency with the highest number. Okay, first step. After you determine the mode class, then you proceed to step 2. Now, step 2, you can either use histogram, which you also learned last lecture. You still remember how to draw histogram, right? Okay. Or second method, you can use this. You can see here, it's like an interpolation method as well. But the formula here is definitely different from the median. Alright. Now, some of you, again, if you have learned this in your early maths, you may have seen this formula to calculate the mode. Right? So what's LM? Same thing, LM also refer to the lower boundary, okay, of the mode class. FM refer to the frequency of the class mode. Now, here, watch out, there are two frequency here, extra frequency. Beside the frequency of the mode class of FM, you still have 1 and 2 here. FB is the frequency before. Now, the easiest way to remember, B means before the mode class. What's the frequency? A means the frequency after. A means after, B means before the mode class. Okay? And the C is the size class of. Remember, you can take upper boundary minus the lower boundary. Right? Okay. Now, I want to ask all of you, if you still remember last week, when we draw histogram, remember histogram? If you remember, I said it can be equal size. If it's also can be not equal size. How many of you remember this? Yes or no? Can you type yes or no? The answer is yes, right? Okay. So for equal size, you don't need to adjust frequency, right? You just draw a histogram based on the class boundary and the frequency. But for those not equal size one, you need to what? Adjust the frequency. Remember? Okay. So you need to use the formula. Do you still remember the adjusted frequency formula? Common class times given frequency divided by the class size, right? Yeah. So when you use histogram or you use the mode, anytime you want to use histogram to estimate or you use this formula to calculate the mode, if the class size is not same, you must adjust it. So you look at here, the note. If the formula is used to compute the mode for frequency that is not same size, underline, highlight this word, unequal size, you must what? The frequency will be replaced by the adjusted frequency. Anyone don't understand? So whether you use histogram or you want to use the formula to calculate the mode, if it's same size, no issue. If it's not same size, you have to use the adjusted frequency, not the frequency. Frequency will be replaced by adjusted frequency. Understand or not? So I write here, same for histogram. We cannot use the frequency. Those class is not the same one, we have to adjust. So we use the adjusted frequency. Okay, anyone don't understand or miss the class, you can replay the video. All right, now let's look at the example now. Again, I use the MetaPipes. Same for mean, median, and mode. I use the same data, MetaPipes. This is what? Length. So it's continuous, right? Okay, so here, point form. We don't have a gap, very close. So this is the frequency. Now, find the mode for this line of MetaPipes. First thing, use histogram. Second thing, use formula. Okay, now, again, what are the things that you need to check? Same size or not same size? Am I right? So what is the class boundary here? Can I write here? 10 to 20, right? 20 to 30, 30 to 40. Okay, everyone, can you tell me the class size here, same or not same? Upper minus lower, right? Okay, there's no gap, so you can straight away remain as a class boundary and class limit is the same. So this 10, 10, 10, 10, 10, 10, 10, 10, and 100 minus 90 also 10. All these are same size. So no need to adjust the frequency. If you do your tutorial or past revision, you find that all class size are same, straight away you draw your histogram, take out your graph paper, then you draw your histogram. Again, this is the line based on the class boundary. This is the length of, sorry, this is the pipes, number of pipes, sorry. Number of pipes is the frequency. Okay, this is your scale, 10, 10, 10. So you can put here 1 cm for 10 unit. If 2 cm, I worry not enough, right? So you put 10, 10, 10, 1 cm. Okay, this one, number of pipes, 0, 5, 10, 15, 20, up to 40. So maybe here you can put 1 cm for 5 unit. Oh, if you can fit in 2 cm, better. All right, now you start from 10. Remember, you can push everything to same y-axis. Start from 0 here, 10 to 20. You get 3 metal pipes. So it's around here. 20 to 30 is about 7 metal pipes here. Okay, 30 to 40, you have 10 metal pipes here. Again, you do the rest up to the 90 to 100. You have 4 metal pipes somewhere around here. Everybody okay? So you see your histogram all joined together one. Can you see or not? There's no gap. Oh, make sure histogram there's no gap. It's joined together. That's why your data here, make sure no gap. Okay? And also this will explain why the discrete data, if there's a gap, we need to close the gap because the histogram here cannot have a gap. It must join together one side by side. All right. So based on this nice, beautiful histogram, everyone, can you tell me how to estimate the mode? Okay, this is your title. Histogram shows the length of metal pipes for a particular day. Right, label all your axes. So based on the histogram, look at the highest chart here. Everyone, can you see this right now? Listen carefully. To find the mode, we take this one edge here, join to one edge here. So we draw one line like that, and then this edge join to this edge. Not here to here or here to here. This edge to this edge. This edge to this edge. Okay? I see some people, they join here wrong. Then this intersection point, this is your intersection point, right? If you draw down, from here, you draw one line down, sharp, and that will estimate your median, sorry, your mode, which is 54. You try and see, everyone. After this, use your actual graph paper and try to draw for this example. You get the mode as 54. Can? So you can, your graph not too big and not too small. The scale I suggest you can use bigger. Make sure it's fit in. Now this is for the same size. 10, 10, 10, 10. No need to adjust. So whether you use the formula or you use the histogram, no need to adjust. Everybody clear? Just use the frequency. Okay, before we go to the formula, so I draw the histogram already, estimate 54. Can we comment, if the question asks you to comment, how do you comment? Everyone, how do you comment the mode? Your question about what? Length of metal pipes, right? So how do you comment? Most of the, you want to see the word most. majority of the metal pipes has what? Has length of 54 centimeter. So I want to see the most of the pipes has the length of 54 centimeter. Okay, everybody? You do your tutorial question, you do your partial, whatever, you always see the comment one. So make sure you write the comment, otherwise you lose the mark. Okay, now, after knowing how to estimate using histogram for mode, let's look at the formula which you have seen here to calculate the mode. All right. Now, this is based on same class, equal size. So again, for the formula, let's find the mode class first. Remember the mode class here. Determine the mode class first. Step one, how you know the mode class? Look at the highest frequency. So based on these metal pipes, the frequency, the highest is what? 34, right? This is your frequency, 34 is the highest. So the mode class is 50 to 60. That's why you write here the mode class is 50 to 60. Okay. And then the formula to calculate the actual mode, Ln plus this one, remember? So Ln refer to 50, the lower class boundary, 50. And then plus FM, FM refer to what? Remember, FM refer to the frequency of the mode class. This is your FM, which is 34. This is before. Remember, before means B, 16. 13 is the after. Right? Before 16, after is 34. The median, the mode frequency is 34. So we put all this into the formula. So plus FM 34 minus FP 16, right? Divided by 2 times 34 minus the FP 16 plus after, which is 13. Then times C. What is the class size? Upper minus lower. 16 minus 50 is 10, right? Which I show you here, or 10. Okay, so calculator, times plus minus divide, you get 54.62. Now, you see, when you do calculation, you're bound to have point form. But when you estimate from graph, everybody listen, when you estimate from graph, it's very hard for us to estimate 1 decimal point, right? Because the graph is very small already, small square box. So very hard to estimate. The most you can estimate is 1 decimal point. That's why we give the accuracy of plus minus 0.5. If you can estimate 2 decimal point, I salute you. Because it's very small, very hard. The most you can estimate 1 decimal point. So we allow this. But if you do calculation, you get 2 decimal point and 54.62. So it's a bit different now. Calculation 54.62, graph histogram is 54. So it's okay because we know that estimation by graph is always a challenge. So you must draw your scale and your graph as accurate as you can. All right, so what is the comment here? As I mentioned, the most common, or okay, say most metal pipe has the length of 54.62. Or you can say the most common length of metal pipe is 54.62, also can. Everybody okay? Any questions? Okay, now this is based on equal size, so you no need to adjust. But we don't have example for unequal size, you see? Finish already. So I always ask my course coordinator, can you put one example for unequal size so that everybody can see the example, how we adjust the frequency. But the tutorial question have questions where there's not equal size. So I suggest you all do the tutorial questions. Careful, it's not equal size. I repeat, you have to adjust. Use this adjust frequency to replace the frequency. Okay. And also, if you draw histogram, you cannot use frequency. For histogram, if you adjust, here must be what? Adjusted frequency. Class boundary, no issue. You still can use the class boundary, but the frequency here must use the adjusted frequency. The rest, normally we use frequency, right? So that's the difference. Okay, everyone, you try lah. You try first. No choice because there's no example for not equal size one. Okay, the last one before we end. What's the good thing and not good thing, advantages or disadvantages for mean, median, and mode? Now, as we compare mean, median, and mode now, we can see that mean the advantage is easily to understand. Everybody know how to calculate mean, right? Plus and divide. So the value of each item is included in the computation. Thus, it has the kind of exactness. See, when you calculate the mean, every number, it doesn't matter whether 5 number or 10 number or 100 numbers, all the number must be included into the total. Remember, you total all the X. Doesn't matter, like even you have 1 million data, you add it up all, divide by the total. So that's the good thing of mean. It has the accuracy, the exactness, high accuracy compared to median and mode. It is also well suited for further analysis. Those who do survey and analysis research, after they get the mean, they can use the mean to interpret future, or you can say further analysis. So you don't look at down mean, even though it's easy to calculate, it is very useful for further analysis. Okay, because it's very high accuracy. Exactness means we can call, say, high accuracy. That means the info we can get is very useful. But what is the disadvantage? Value may not be correspond to the actual value. Okay? For example, the average number of children is 2.4. This is what somebody asked me that day. I mentioned that children is discrete, right? Children is discrete. So if you get 2.4 children, remember that day we learn discrete data and continuous data. 2.4 children means 1 child, 2 child, and then cut into 0.4. Yes, we know children cannot be 0.4, but in exam, allowed to write 2.5 children. This is for exam purpose. Not everyone I mentioned that. So we ignore the logic of the 2.4 there. For exam purpose, no choice. Okay, unless we give question that involve accurate number of children after you calculate the mean and so on. So that is what we call it may not correspond, means support the logic for certain variable. After you find the mean, you are bound to have point form, then it's not logical. But for exam purpose, okay, they accept that. Anyone to understand what I mean? Okay, now the other disadvantage, this one I want you to understand here. You see, if I give you 5 data, 5 number here, 5 person income, example, 200, 250, 300, 500, and 6,000. If I rearrange it, you can see that this is my what? Data. I arrange in order lah. Now you can see that if I find the mean, I total up all this number. Right? You divide by 5, I get 1450. You try and see, everyone, calculator, add it up, divide by 5. Now, here, you will see the word distorted by a field extremely high or low. This is the highest. This is the lowest. And where is the mean? The mean is 1450. Everyone calculate already? So it's here, the highest is 6,000. The lowest is 200. Can you see the different? Distorted means what? The difference. Difference, you all know what's called difference? Between 200 and 1450, what's the difference? 1450, if you minus 200, you get 1250, correct not? If you take 6,000 minus 1450, it's about 5,000 plus. You see how much difference there? Highest and the lowest difference from the mean. You see here, the mean is now distorted or pulled up by one person income of 6,000. Because of one person high income, 6,000, the mean pulled up become 1450. Whereas the majority earning is only between 200 to 500. You see this four number, right? It's very close, right? How much the difference here? 200 to 500, almost different by 300 only. This phone income is about the same, but this one suddenly extremely, we call it extremely high. Because of 6,000, then the mean become 1450. Otherwise, if you take this phone number divided by 4, it's about 1,002 divided by 4 is about 300 something. 300 something. But now become 1,400 because of this. So that's why we call it distorted. Understand? So when you do a tutorial or passive question, they will ask you, is this mean suitable for this type of data? The answer is no, because of 6,000, the mean already distorted. So the mean here is misleading. You all know what's called misleading? Cannot be trusted. Understand? Okay. So it means that if everyone's score is C, and then suddenly the person's score is A, something like that. I'm not saying the person's score A is cheating or whatever. Or you can say everybody's score is 1, 2, 1, 3 like that. Suddenly this person's score is 100. Then what happened to this score? Misleading, right? You may want to investigate why this person score 101. Everybody score between 1 and 10. Then suddenly this one, you have to take care already. Anyone to understand? Okay, so if the question asks you, you must mention, is the mean suitable here or not suitable? Is the median and the mode suitable? Okay, let's look at the median now. What's the advantage? It's the middle value, right? It is not affected by the extreme value. You see, whether the value have extreme or not extreme, we take the middle value. You arrange, you take the middle value. Let's say this is your middle value, 300. So always safe one. This is usually preferred than mean where the extreme value. So if the data have extreme value, don't choose mean. Choose what? Choose median. It's more preferred than mean. So if data has extreme value, choose what? Choose median. Don't choose mean. Okay, everyone? But the disadvantage of median is it does not reflect the full range. It is not suitable for further analysis. Compared to mean, further analysis is useful. Okay, the last one, mode. It is most appropriate average where it's useful to know the most common value. So if you know the situation where you can find the highest frequency or most common value, For example, the purchasing department in a store for selling shoes, they know what is the most popular shoe size. Then if you know that, you can use the mode as the measure for central tendency. Other than that, if you don't know the popular number or the common value, then very hard to comment about or very hard to, fix the mode. So that's the advantage. Now, easy to find, just look at the most occurrent, and it's not influenced by the extreme value also. So if the data has extreme value, choose median, or you can choose mode. Okay, the disadvantage, ignore the dispersion. Now, I'm going to talk about dispersion in chapter 2b. So for those of the data have dispersion not suitable for mode because it ignore. Same like your median, it is not suitable for further analysis. Only mean suitable for further analysis. Okay, and then it's not unique. Now, just now I mentioned, right? Sometimes there's no mode. Sometimes can be one mode, can be two modes. So it's not unique. This is the disadvantage. So you want to work in a situation where, as I said, you know the common value, right? If it's one mode, then it's okay, unique. But if it's not unique, useless already. Okay, you cannot comment about the mode. Might as well you use mean or median to comment about your data in terms of central tendency. All right, now this is your tutorial 2A for your Chinese New Year homework. Okay, next Monday no class, we already replaced. So you can finish all this before your Chinese New Year. This is your final answer. Now you have to use graph paper, everyone. Without graph paper, you cannot get the accurate answer. Now, we have few more minutes. You can try these questions if you want to, or you can do after this when you take a break. This shows the number of cars sold by a second-hand car dealer for 50 days. So this is the number of days. If you total up, maybe 50 days. This is the number of cars sold. For 8 days, you have 1 to 2 cars. 14 days, you have 3 to 4 cars. Again, this is what? Number of cars sold is discrete. So you can see here, there's a gap. So you need to close the gap, plus minus 0.5. Am I right, everyone? Okay, 11 and above. Can you all tell me what is that? Yeah, I know, but what is the value here? 11 and above means 11 to what? $14, Ziyan, Liu and get Dongsheng. Yes. How I know it's 14? Remember, this is the open-ended one, right? Above, below, you must know how to write. Otherwise, you cannot calculate the mean, median, and the mode. You write wrongly, also wrong. So how we know it's 14? Because this is class size, right? Remember the class size? This is, you close the gap already, right? 2.5 minus 0.5 is class 2, 2, 2. This one is what? 4. So the last class will follow the preceding. This is 4, so this one follow 4. So 11 to 14, and then you close the gap 10.5 to 14.5. Okay, everyone? Then you try find the mean. You need to find the class mark, with class, use the formula. Then the median, use the formula. The mode, use the formula. Okay, this is the answer. And then don't forget to interpret your answer. Okay? For mode, this is not same size, right? You need to adjust frequency because this is class size 222 and this is 4. So you need to adjust the frequency for the mode Otherwise, you won't get the answer. Okay, not everyone. Okay, any questions? You need to adjust frequency for mode. Okay, bye-bye. And I see you all after the Chinese New Year. All the formula for exam, yes, but not all. Only certain we given. Okay, so I wish you all to have a good, happy Chinese New Year. Tutorial still go on, don't forget. All right, have a good celebrations and take care and do your tutorial as usual. For group 2, Brian, group 2, I see you right today. Make sure your group, your course mate ready to present the answer to me, Brian. Okay, use the Jamboard. Use Jamboard. Okay, I post a video after this in the GC. That's all. I stop presenting now.